explain and solve, it will be okay. Okay, so this is the second part of our lecture, which is about measurement of variables. We have the scaling. What do we mean by scaling? Reliability of scaling and the validity of scaling. So first, we need to know what we mean by scaling. Measurement means gathering data in the form of numbers, because as we said, all statistical utilities deal with numbers. So you need to transform your data that you have collected into the form of numbers. To be able to assign numbers to attributes of objects, again, we have objects. Okay, these objects have attributes or characteristics. These attributes we will assign some kind of values. These values will be numbers or symbols. Okay. So to be able to assign numbers to attributes of objects, we need a scale. We need some reference scale. A tool or mechanism by which individuals are distinguished as to how they differ from one another. For example, to differentiate the length or the height of the person, of the people, we have this reference scale. For example, this meter. Yes. So this is the scale. It is used to distinguish how those people differ from one another on the variables of interest to our study. For example, if we choose the height or the length, so it would be now the variables of interest. We are trying to get the value of length or height. So length is our variable of interest. So the attributes or characteristics are our variables that we are seeking to measure. So again, to be able to assign numbers to attributes of objects, we need a scale, which is a tool. That's something you can use or utilize, or mechanism. It could be a mechanism, okay, by which individuals are distinguished as to how they differ from one another on the variables of interest. We have 4 types of scales in statistics. 4 types, 4 basic types: nominal, ordinal, interval, and ratio. The degree of sophistication, how these scales are complicated, to which the scales are fine-tuned, increases progressively as we move from the nominal to the ratio scale. So how these sophisticated? This one is the easiest one, which is the nominal. Then this is complicated or sophisticated than nominal. Interval is more sophisticated, and ratio is the most sophisticated. So it is, if you put this measure or this line, the degree of sophistication to which the scales are fine-tuned increases progressively from the nominal to the ratio scale. So this is the most sophisticated, and this is the most easiest.
Interval and the ratio
we will see now. We'll explain it to everyone. Okay? Everything is okay? I hope so.
How these variables are using equal sales?
you can conclude these variables. We said variables are attributes.
Yes. Variable represent what in my research? Problem or
It is the faces, the dimensions of your problem. If you study your problem from different dimensions, from different facets, then each attribute or feature could be one variable. Okay, so the first one, which is the nominal scale. A nominal scale is one that allows the researcher to assign subjects to certain categories or groups. For example, what is your department? Is it marketing, production, sales, maintenance, services, servicing, public relations, finance, personnel, accounting? So it is precisely you assign your variable, which is a department, to only one value. This is what we mean by nominal. It's one that allows the researcher to assign objects. This is our object, which is the department. Okay? To certain categories or groups. You need to choose which category or which group you belong to. Another example, your object is the gender. So what's your gender? It is either male or female. Okay? So it is nominal. Also, these are some examples of nominal scale. What you can understand from this drawing. Just think about it.
We have some number.
One first number.
We're assigning as a number today.
The way.
What was the meaning?
The thinner one.
reason?
First, I think the scale would be the weight. Yes, the second one would be the chamber. Yes, the
What's the scale?
The weight.
First one?
Is the weight.
Weight.
Weight of the.
Weight of result.
What then is
It's in one place.
Okay.
On the speed could be also what. What's obvious is the weight. So it could be also the speed.
Okay. So what are the groups?
One.
How can you assign them to groups?
This young
The fact
is
is, can be the fact and sleep. Obese and slim. The second would be male or female. Gender, different gender.
This one.
First, male, two groups. First group is male,
These are male, these female.
female.
Okay. So we cannot give value. It is just grouping or categorizing. Groups or categories. So this is the nature of the nominal scale. It's like grouping or categorizing in groups or in categories. So you cannot give specific value. The second one is the ordinal scale. Not only categorizes variables in such a way as to denote differences among various categories. It also orders categories in some meaningful way. So here we have a rank of orders. Rank of orders. For example, what is the highest level of education you have completed? Could be less than high school, college degree, master's degree, or doctoral degree. So here also you are categorizing, but you, in addition, you have ranking, you have order for the values. Okay? You have ordering. This is the first. You can say this is the first rank, doctoral degree, and then master's degree, college degree, high school, and less than high school. This is what we mean by ordinal scale. It is not only categorizing variables like nominal, okay, in such a way as to be no differences among various categories. Here we show how these categories are different from each other. They are different from each other by the rank, the order. This one is more on the top. This one is okay after it. This one and this one until the last one. For example, here, ordinal scale. Look for those athletes. This is the first, this is the second, and this is the third. And also for the students, good, better, best. Okay, the third one is the interval scale. In an interval scale or equal interval scale, sometimes they call interval scale, sometimes also called equal interval scale. Numerically equal distances on the scale represent equal values in the characteristics being measured. If you have a characteristic or attribute that you want to measure, so on the scale, the equal distances between 2 points, okay, equal distances on the scale represent equal values. Allow us to compare differences between objects. The difference between any two values on the scale is identical to the difference between any other two other neighboring values on the scale. This is an example for the interval values. This is a thermometer for measuring the temperature. You see 0, 20, 32, 40, 60, 80, 100. So this is the scale. This is the degrees in Fahrenheit, and this is in centigrade. So you have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. If you choose any 2 points from here, you can see the distance between them is identical to the distance between another neighboring 2. For example, here, in between 10 and 20, the distance is 10. And also between 20 and 30, the distance is 10. Between 30 and 40, the distance is 10.
Have equal interval.
Yes. So this is what we call equal interval scale. Have equal distances on the scale represent equal values in the characteristics. So the characteristic here is the temperature. Okay? So this kind of scales allow us to compare differences between objects. The difference between any 2 values on the scale is identical, is similar, identical to the difference between any 2 other neighboring values of the scale. Okay? And also here we have a questionnaire which has 10 scales. The number 1 is very low and number 10 is very high. But the distances between each 2 points is equal. It is identical. The clinical thermometer is a good example of an interval scale instrument. It has an arbitrary origin, and the magnitude of the difference between 98.6 degrees, which is the normal body temperature, and 99.6 degrees is the same as the magnitude of the difference between 104 and 105, because here the difference is 1 degree and also the difference is 1 degree. And also here we show that the origin is arbitrary. It is not. It is random. You cannot say that the beginning or the point or the 0 point is like this. You don't have origin or 0 point in this kind of interval scale. Okay? Has an arbitrary origin. يعني ما فيش نقطة مصدر ممكن تقارن فيها. البداية عشوائية. The last one, which is the ratio scale. The ratio scale overcomes the disadvantage of the arbitrary origin point. Here we have arbitrary origin point for the interval scale. So this is considered as a disadvantage. So to overcome this disadvantage of the arbitrary origin point, the interval scale, in that it has an absolute in contrast to arbitrary. So we have absolute 0 point for the ratio, which is a meaningful measurement point. For example, what's your age? The origin point for the age is 0. Because this is the minimum value, 0, for the person who just born. Okay? And also for the weight, the value is 0. This is the origin value. Then you can compare. But for the temperature of the body, there is no origin. You don't have origin point. So which one you would choose? Select ordinal scale or interval scale. Circle the number that represents your feelings at this particular moment best. There are no right or wrong answers. Please answer every question. Invest more in my work than I get out of it. You have a scale from 1 to 5. 1 means I disagree completely, and 5 means I agree completely.